Welcome to the third module of chapter number 12, Sound. In this module, we will be learning reflection of sound, good and bad reflectors of sounds with examples. We'll discuss echo and reverberation of sound. Also, we will study various parts and their functions of human ear and the functioning of human ear in detail. Sound waves also follows the laws of reflection. Let us do one activity. Make two sufficiently long identical tubes of cardboard. Arrange them on a table in front of a wall or a hard surface as shown here in the figure. Place a clock near the end of one of the tubes and try to hear the ticking of the clock at the end of the other tube by placing your ear here. Adjust the angles of the two tubes till you can hear the sound very clearly. Measure the angle of incidence I and angle of reflection R. Try to see if they are related in any way. You will find that the direction of the incident sound wave and the reflected sound wave make equal angles with the perpendicular to the surface, and all these three lies in same plane. Also, you will find angle I is always equal to angle R. Sound wave also gets reflected as light waves do. Bouncing back of sound wave from the surface of solid or liquid is called reflection of sound. How much of the incident sound gets reflected decides whether a reflector is a good or a bad reflector. The objects which reflect sound and have a hard and smooth surface are good reflectors of sound. For example, wall, metal surface, hard wooden surface, etc. Materials are the objects which absorb sound instead of reflecting it and are soft, porous, are called as bad reflectors of sound. For example, cloth, paper, carpets, etc. These materials are also called as sound absorbing material and are used to reduce the reflection of sound. You must have visited an echo point at a hill station. If you shout loudly at such a point, you hear the same sound just after a little while. This sound is called an echo. An echo is the repetition of the original sound because of reflection by some surface. In order to be able to hear the original sound and its reflection distinctly, what must be the minimum distance between the source and the reflecting surface? Let us find out. When we hear any sound, that sound our brain retains for zero point 0.1 second. Thus, for us to be able to hear a distinct echo, the sound should take more than zero point 0.1 second after starting from the source to get reflected back from the reflecting surface. Thus, we can determine the distance between the source and the reflecting surface so that one can be able to hear a distinct echo. Let us determine the distance between the source and the reflecting surface so that one can be able to hear a distinct echo. We have the formula distance is equal to speed into time. The velocity of sound in air is 344 meter per second, and we know that our brain retains a sound for zero point 0.1 second. So we have the time as zero point 0.1 second. So we get distance is equal to 34.4 meter. Now this is the total distance that the sound covers from the source to the reflecting surface and again from the reflecting surface to the source. So to be able to hear a distinct echo, the reflecting surface should be at minimum distance of half of this distance, that is 17.2 meter. Echo can be heard multiple times due to continuous or multiple reflections. The Gol Ghumad at Bijapur in Karnataka is an excellent example of this. The Gol Ghumad is a historical monument located at Bijapur in Karnataka. It has a smooth circular interior of a large circumference with a dome above it. Due to the circular structure, sound waves generated at one spot get reflected multiple times before coming back to the same spot, resulting in production of multiple echoes. Let us know about reverberation. In reverberation, sound waves gets reflected from the walls and the roof of a room multiple times. This causes a single sound to be heard not once but continuously, and this is called as reverberation. Echo and reverberation are completely different. In case of echo, we can be able to hear the reflected sound very clearly after an interval of time. But in reverberation, as the time between successive reflections of a particular sound wave reaching us becomes smaller and the reflected sounds gets mixed up and produce a continuous sound of increased loudness which cannot be heard properly or clearly. The ear is an important sensory organ of human body. We hear sounds because of our ear. Ear can be divided into three parts. Human ear is an organ of hearing that detects and analyzes sound and maintains the sense of balance. As you can see here, the ear is divided into three parts, namely outer ear, middle ear, and the inner ear. Now, let us study the organs involved in all these three parts of the ear and their functions in detail. Now, let us try to learn the location and functions of various parts of a human ear. Here you can see outer ear, which is also called as pinna, collects the sound waves and passes them through a tube to a cavity in the middle ear. The pinna is peculiar funnel-like shape which helps to collect and pass sounds into the middle ear. There is a thin membrane in the cavity of the middle ear called as eardrum. When a compression in a sound wave reaches the eardrum, the pressure outside it increases and it gets pushed inwards. The opposite happens when a rarefaction reaches there. The pressure outside decreases and the membrane gets pulled outwards. In this way, sound waves cause vibrations of the membrane called eardrum. The auditory nerve connects the inner ear to the brain. The inner ear has a structure resembling the shell of a snail and it is called as cochlea. The cochlea receives the vibrations coming from the eardrum and converts them into electric signals which are sent to the brain through the nerve. And the brain analyzes these signals and one can come to recognize the particular sound heard. The ear is an important sensory organ of the human body. Sticks or the other pointed objects should never be inserted into the ear for cleaning it. Also, one should not hear very loud music using earphones. It may cause a serious injury to the eardrum.